Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep. Yes guys, so once again live with the GATE 2023 Engineering Mathematics sessions, and yes, we started with the calculus in the past few days, and we have learned the concepts of indeterminate forms, the concepts of limits. More importantly, we have learned the concepts of continuity and differentiability, and not only we are learning the concepts, we are also looking into the question practice. So the next concept, the next topic that we are going to now look into is the mean value theorem, another important area from the calculus, that is the mean value theorem. And you know, the basic foundation that is just required to study the mean value theorems is continuity and differentiability. And I hope, yes, if you have followed the previous classes, so we have learned continuity, differentiability in quite some good depth. Need not worry about this. Where do we get the PDF of the 2 days classes? Sai Charan, yeah, just comment once only, that is fine. PDFs is there in the Telegram only, Sai Charan. PDFs will be available in the Telegram, and let's get started with the class. What is the Telegram? If you're not aware about my Telegram group, I'll share you the link of the Telegram as well, isn't it? Yes. All right, yes guys, so let's get started, and quickly everybody share the session to your friends, update your friends that the session is live. This is a brief intro about me in case somebody new to my session. This is your mentor and educator Rakesh. I have secured all India rank 9th in the GATE examination, completed my masters from the Indian Institute of Science, Bangalore. Right, having more than 11 years of experience, have trained more than 50,000 students in my journey, where my major technical area will include digital electronics, control systems, signal and systems, and electromagnetic theory, and I also deal with the maths and aptitude in the general domain. Right. All right guys, so this is what is the schedule of the classes. I'll get the updated, I'll tell you the schedule verbally as well in a better form. Right guys, so mean value theorem, let's get started first of all with the Lagrange's mean value theorem. In short, the Lagrange's mean value theorem, in short we call it as LMVT. We call it as the LMVT, the Lagrange's mean value theorem. The Lagrange's mean value theorem. So if fx be a real valued function, if fx be a real valued function such that number one, it is continuous in the closed interval a comma b, it is differentiable in the open interval a comma b. Right, so continuitically you are able to see I'm using close bracket, differentiability I'm using open bracket. Why it is so, we'll get the things clear, but yeah, I hope you know that open bracket means not including the endpoints, close bracket means including the endpoints and all the values between a and b. Right. Then what happens? That's what we'll learn. Then I will put the conclusion. So let's say we have a function which is continuous and differentiable. Right, we know what is the condition for continuity and differentiability. Let us try to understand this with the help of a graph. Okay, let us try to understand with the help of a graph. Consider a particular function. Okay, consider any particular function, as you are able to see here. This is a function fx. This is any function fx. Right, it can be any random function fx. Now you are able to clearly see this graph, everybody. Now you are able to clearly see this graph. In the graph for the function fx, in the graph for the function of fx, what you are able to see that there is no jump. See, what were the three common cases of discontinuity we learned? Either there is a jump in the value of the function, or either there is some undefined value going to the infinity, right? Either there is a breakpoint, something of this kind, right? So we know that this is a smoothly varying continuous graph, right? There is no h point. You can define the tangent at any point, and hence it is also differentiable. Can you define the tangent? Because what is derivative? One of the way of looking into derivative is the slope of the tangent to the curve at that point, right? Let me take any particular point. Let me take any particular point. Okay, let me take any particular point. Let's suppose I take this point, and let's draw the tangents at that particular point. Okay, suppose I take this point. So what is the tangent to the curve at this point, sir? Right, now what is the slope of this tangent? The slope of the tangent actually represents a derivative, na? The slope of the tangent. So slope of the line is basically, if I extend this, is basically the tan theta. The angle theta is the angle which is subtended with respect to the x-axis. So definitely the tan theta is going to be a finite value. Only thing is, if the vertical line is there, third condition of third failure condition of differentiability, I told you, function should not have a vertical line tangent. Is it a vertical line? No, it's an inclined line where the theta is an acute angle. It is not 90 degree. This theta is not 90 degree, and not only for this particular point, guys. Let me take any more point. Okay, suppose I take this point. How is the tangent to the curve at this point? How is the tangent to the curve at this point? ये देख लीजिए, right? Okay, so when you extend this also towards the x-axis, what is the angle that it is going to measure? It is again a acute angle, and the tan theta is not going to be infinite. मतलब all the value of the slopes are going to be finite. So let's take this point also. Any point. If you take, see what is the effect that you are going to see, right? Yeah, this is going to become, see, suppose this is the x-axis, parallel to x-axis. So when you take this angle theta, this will become obtuse, right? But at least the value of tan theta, the tan theta may be negative, the slope will be negative, but it is not infinity. Now it is a valid problem. Okay, it is a valid value. Voice is breaking. Voice mic problem. Yes, guys, quickly confirm me whether the audio issue or video issue is there with the others also. Or is it all fine? Right. Chalo. Yeah, maybe a small glitch came, but I think it's okay now for all. Okay. Yes. So this particular function is differentiable at all the points. It's differentiable at all the points between A and B, and hence I can draw the tangent to the curve at any of these points. Acha. Now, because I can draw the tangent to the function at any of these points, there comes a point somewhere. Between A to B. Let's suppose that point is known as the x equal to c. That point is known as the x equal to c. There comes a point somewhere between A to B, suppose x equal to c, where out of the so many tangents to the curve, there comes a tangent which appears parallel to the line joining A and B. And now we have written this as a second line, a secant line, because this is the line which is intersecting the curve at 2 points at least, right? Now, there comes a tangent which is parallel to the line joining A and B. Now, what is the condition for parallel lines? Their slopes are equal, right? So what is the first thing I told you? The function is continuous and differentiable. Since the function is differentiable, we can draw the tangent to the curve at any point, because the derivative is directly equal to the slope of the tangent, right? We can draw the tangent to the curve at each of these points, and all of these tangents, amongst all of these tangents, there come a tangent which is parallel to the line joining A and B. Acha. Okay, so that means the tangent at the point C, let's say if I name this point, let's say the point is C. So the tangent to the curve at the point C is parallel to what? It is clearly parallel to what? It is parallel to the straight line AB. It is parallel to the straight line AB. Okay, sir, it is parallel to the straight line AB. Now, if two lines are parallel, okay, so if two lines are parallel, the slopes will be equal. Okay, the slope of the tangent at the point C should be equal to the slope of the line AB. Okay, now what is the slope of tangent at the point C? Boliye. What should be the slope of the tangent at the point C? The slope of the tangent is known as the derivative of the function. So derivative of the function at the point x equal to C should be equal to slope of line AB. Now what is the formula for slope? What is the formula for slope of line when the points are given? So it is given by y2 minus y1 upon x2 minus x1. What are the 2 points? Now what is this point? Let me write down. What is this point? This is x1, y1, where value of x is a. So what is the value of y is fa. Right. What is the point b? x2, y2. What is the point b? It is b comma fb. Okay, so I have the 2 points, right? x1, y1, x2, y2. Right. So writing down the values here, it becomes the fb minus fa is divided by the b minus a. It is known as the fb minus fa is divided by the b minus a. fb minus fa is divided by b minus a. Okay. fb minus fa is divided by b minus a. Right. So there comes a point in between a to b where the slope of the tangent will be equal to fb minus fa upon b minus a, and this is what is the conclusion. So up to this point I have already written, let fx be a real valued function such that it is continuous and differentiable in a comma b. Okay, it is continuous and differentiable. Now see, continuity is required in the closed interval a and b, because the function should be continuous in a and b, because I'm using the value of fb and fa. If the function is not continuous at a and b, the theorem fails. We cannot use the values of fb and fa. Okay, so since fb and fa are involved, it is very much necessary that the function should be continuous in the closed interval ab. But yeah, the tangent that is coming, it is in between a and b, right? So tangent is related to what? The slope of tangent related to the derivative, right? So it must be differentiable somewhere between, it should be differentiable at all the points between a and b, not necessarily at the end points. That is why here open interval was used. Okay. So this is what is the condition and conclusion of Lagrange's mean value theorem. Now you will think about this, sir, what is the application of this theorem? Why this is known as the mean value theorem? What is the application of this? So don't worry guys. Okay, what I have planned, what is the schedule I have made for you, this is systematically. What I'll try to do is, today I will explain you all the theorems. Lagrange's mean value theorem, we have the Rawley's theorem, and we have the Cauchy's mean value theorem. These are the 2-3 different things. Lagrange's mean value theorem, Rawley's theorem, and Cauchy's mean value theorem. We will take some basic questions also. Eventually the next class is the applications of mean value theorem. The next class will be the applications of mean value theorems, right? So in the next class we will discuss about the application key, where all, okay, today we will see normal problem, but all the different areas where this mathematics can be applied. Okay, जो directly आपको समझ में नहीं आएगा, how a different problem, altogether a different problem, can be thought with the help of Lagrange's mean value theorem. That's what we'll see in the next class also. So there are 2 classes, mean value theorem and applications of mean value theorem. The applications class will be the next class, that is, today is Monday now, so that will be of course Wednesday 6 p.m. Okay, so that is what it is. Achha. So let's get ahead. Let us get moving. Rawley's theorem. So one more condition we add in the Rawley's theorem. Okay, if a function, let there be a function fx, okay, a real valued function such that, same sir, it is continuous in the closed interval a comma b, it is differentiable in the open interval a comma b, and also one more condition, that the value of the function at a and b should be equal. The fa is equal to fb, and because I am taking fa equal to fb, what is going to happen? Because these two are equal, so fb minus fa will become 0. The fb minus fa will become 0. So it is just a special case of Lagrange's mean value theorem, you can say. Okay, then there exists a point x equal to c in between a comma b such that f dash c is equal to the 0. Such that f dash c is equal to the 0. Such that the f dash c is equal to the 0. Okay, there exists a point x equal to c belonging to the interval a comma b such that the f dash c equal to 0. Correct? Okay, just a previous case of this. If you want to have a look into the image, you can see what will happen if the fb and fa are equal to, if the fb and fa are equal. Okay, yeah, this is x equal to a, and this is what is the value of fa, right? This is the point a, right? And this is what is the, it goes up to here, this is what is the point b. okay, which is B comma FB, but FB is equal to FA. FB is equal to the FA. Now, because they are equal, once again I will put the same theory if I have to describe. Because the function is differentiable at all the points, so there can be so many tangents that can be drawn to this curve. There can be so many tangents that can be drawn to this curve, and out of all these so many tangents, there will come a tangent at the point C. There will come a tangent at the point C which is parallel to the line joining AB, but FB and FA are equal. So because height of both the points is equal, the tangent is parallel to AB and hence it appears parallel to the x-axis. The tangent is parallel to AB, same theory like Lagrange's mean value theorem, but eventually it is parallel to the x-axis, and the line parallel to x-axis will have zero slope. The line parallel to x-axis will have zero slope, and I can now say that tangent at C is parallel to the x-axis. The tangent at C is parallel to the x-axis, and hence the slope of the function at that point, that is f dash C, should be equal to 0, because any line parallel to x-axis will have zero slope. That's what it is. The f dash C is equal to the 0. That's what it is. All right, all fantastic. Chalo. Okay, now the next case. That is the Cauchy's mean value theorem. Okay. So what is that Cauchy's mean value theorem? So now I talk about two functions, fx and gx. Both are real valued functions such that both are continuous in the closed interval AB and both are differentiable in the open interval AB. Now consider any one of them which is continuous and differentiable with this condition. So what will that function follow? That function will follow the Lagrange's mean value theorem, undoubtedly. Already this part is discussed. Okay, if there is a function which is continuous in closed interval AB, differential in open interval AB, so that will follow the Lagrange's mean value theorem. And if it follows the Lagrange's mean value theorem, then what? Then we know, we have discussed this, we have derived this, then f dash C is fb minus fa upon b minus a. So now I am telling you that there are two functions, both are continuous and differentiable, so both will be following the Lagrange's mean value theorem. And if both will follow the Lagrange's mean value theorem, so sir, what should be the value of f dash C? It is fb minus fa is divided by b minus a. Then what should be the value of g dash C? चलो इसको divide करके देखते हैं. So value of g dash C will be equal to what? It is equal to the gb minus ga is divided by b minus a. So b minus a anyways will get cancelled, and hence we have the formula that follows in front of you. F dash C upon g dash C is equal to fb minus fa upon gb minus a, provided that gb does not equal to ga, because if the gb and ga are equal, the denominator will be 0, and whenever in the p by q form, if q equal to 0, the quantity stands to be undefined, so the theorem will fail. So gb should not be equal to ga, right? Alright, so that is what is the Cauchy's mean value theorem. As I told you, once again I'll repeat this. Okay, why are they mean value theorems? What all they can compute? What are the applications? All that part will also be discussed and learned. But before going to that, this is the theorem, introduction of the theorem. Okay, basic questions, and then what are the applications of mean value theorem will be in the next class. Okay, so if fx is equal to mod x, for x belonging to minus 1 comma 1 does not satisfy Rawley's theorem, because can you please tell me this answer? Because fx equal to modulus of x, and we had a good discussion on mod function, the continuity and differentiability of mod function, not only mod x, any type of modulus function. Can you guys tell me this one quickly? Yes, guys. fa not equals fb, right? You want? Yes. Thank you. Yeah, what are the comments that you're telling? Not differentiable, fa not equals, option number A, fa not equals. Okay, fa not equal fb. It looks like a strange reply that is coming from the students. Yeah, some of you are correct also. So when, you know, let me give you the sketch also. Now we have discussed the sketch of the modulus function. Have a look into this, guys. Just have a look into this. Just for once, have a look into this. Modulus x, which was forming the V-shaped curve with the slope +1 on the right hand side and the slope -1 on the left hand side. Right, this is fx equal to x, this is fx equal to -x, right? Remember na, what is fx, which is modulus of x, is given as x for x is greater than equal to 0. It is given as -x for x is less than 0. That is what is fx equal to modulus of x. That is what is the fx equal to modulus of x. ठीक है जी? Right. Now, that is for x belonging to -1 to 1. Now, we clearly know that, guys, we very clearly know that what is this known as? This was known as the sharp point. Sharp point or edge point or break point or corner point where the function is continuous but not differentiable. Sharp point is the point where the function is continuous but left hand derivative does not equal to the right hand derivative and the function is not differentiable, right? Since I have discussed this with the continuity and differentiability concept, we will not derive it again, but yes. Okay, is it not continuous in -1, 1? It is continuous everywhere. Is it not differentiable? Yes, it is not differentiable in -1, 1. It is not differentiable at x equal to 0. Right, मैंने क्या बोला? It should be differentiable at all the points between -1 and 1, but there is a point x equal to 0 which belongs to -1, 1, but function is not differentiable. So that condition fails. Now some of you are talking about f -1 not equal to f1, fa not equal to fb. Guys, what should be the value of f1? f1, modulus of 1, modulus of 1 is 1. What should be the value of f -1? f -1 is known as modulus of -1 and that is also +1. That is also known as the +1. So both are equal only, na? Both are just equal, right? So fa is equal to the fb. fa is equal to the fb. fa is just equal to the fb. Right, fa is just equal to fb. So first condition does not fail. Some of you are telling the first condition no. So it does not satisfy Rawley's theorem because it is not differentiable. Option number C. It is not option number A, right? I was just surprised why option number A is coming. Going ahead with the next question now. If Rawley's theorem holds, now clearly they say the Rawley's theorem holds for this function. Acha. What is the three condition for Rawley's theorem? Function should be continuous, differentiable and fa equal to fb. What about continuity, differentiability? Now look about this. Anyways, they have told it holds. You need not check, but just I'm explaining you still for clarity. What is the type of function they have given? So the type of function that is given is clearly a polynomial function. It is clearly a polynomial function. And if it is a polynomial function, I have told you already about polynomial function that polynomial functions are always continuous and differentiable for all values of x. They are continuous and differentiable for all values of x, whether whatever, यहाँ पे they have told 1, 3, tell you whatever interval you take from -infinity to infinity, polynomial functions are always continuous and differentiable, right? So what is the type of function they are mentioning? It is a polynomial function. Only thing is the value of k is unknown. That's what I need to find. It's a polynomial function, right? So hence it is always, for all values of x, it is continuous and differentiable. It is always C and D. It's always continuous and differentiable. It is always continuous and differentiable, right? Now, because it is always continuous and differentiable, so I can say that, okay, I can say that I can say that, okay, number 1, it is continuous. Okay, Rawley's theorem holds, hai na? So I can say that it is continuous in the closed interval 1, 3. Actually continuous everywhere, but let us talk about our interest. Okay, it is differentiable in the interval 1, 3, and number 3, F1 should be equal to F3. And I think that is the point where you can solve the problem. Now there are two methods of solving this. This one is the direct method. One more method I can tell you. F1 is equal to the F3. Now sir, if F1 is equal to F3, right? If I use F1 is equal to the F3, okay, तो पहले Fx लिया तो 1 minus 6 plus k plus 5, that is F1. Now F3, 3 cube is 27 minus 6 into 3 square, that is 6 into 9 plus 3k plus 5. तो 5 to 5 cancel ही हो गया. Left hand side I finally have k minus 5 and right hand side I have 27 minus 54 minus 27 plus 3k. Eventually 2k is equal to 27 minus 5, 22. You get the answer for k, that is equal to 11. The answer for k is the 11. The answer for k is 11. That's it, solved. Yeah, that's what k is the correct, 11 is the correct answer as specified by some students in the comment box. But there can be one more way of solving, but this is the direct method. Okay, now what some other students can think? Ki acha, Rawley's theorem holds, and what is the condition for Rawley's theorem? Okay, what is the condition for Rawley's theorem? That if Rawley's theorem hold, then f dash c equal to 0. Then f dash c is equal to 0, right? So I can use c is also given. Okay. Okay, so what is the condition of Rawley's theorem? Method number 2, right? Rawley's theorem says that f dash c is equal to 0, right? What should be f dash c? What is the f dash x first of all? The f dash x will become, the f dash x will become 3 into x square, then you have minus 12x plus k, right? Now f dash c, that is 3c square minus 12c plus k equal to the 0. That means 3 into, the value of c is given to you, that is 2 plus 1 by root 3. 2 plus 1 by root 3 whole square minus 2 into 2 plus 1 by root 3 plus the k is equal to the 0. So this will be little calculative, I think. This will be little calculative, but just for the sake I have started, let me complete. A plus b whole square, a square plus b square plus 2ab. Okay, plus 2ab minus of this 12 into 2 plus 1 by root 3 plus k equal to 0. Let me just cross check the numbers now. This is 3 4s are 12. 3 and 3 cancel 1. Then this becomes 4 root 3 minus 24. Okay. So this one was also 4 root 3. ये भी हो जाएगा 4 root 3. So this is also going to be cancelled. Plus k equal to 0. So 4 root 3, the third is cancelled. 12 plus 1, 13. 13 minus 4, 11. Right. K is equal to 11. Eventually you have the same answer, but with little bit more calculation. But so that is the method number 2. This is what is the method number 1. Okay, so if Rawley's theorem holds, you can use the condition of Rawley's theorem or you can use the conclusion, right? But I think the usage of condition was much easy calculation as compared to the conclusion of the Rawley's theorem. But yeah, both are appropriate at the same time. Okay, a simple gate question. There are some good questions also of gate of mean value theorem, but that we can discuss after the application of mean value theorem. And as I'm telling you continuously, next class will be application of mean value theorem. A function fx is equal to 1 minus x square plus x cube is defined in the closed interval minus 1 comma 1. The value of x in the open interval minus 1 comma 1 for which the mean value theorem. Now when they say mean value theorem, automatically you have to take Lagrange's mean value theorem. Okay, so what is the value of x for which the mean value theorem is satisfied? For which the mean value theorem is satisfied. Please tell me. It's based on the simple question based on the Lagrange's mean value theorem. Based on the Lagrange's mean value theorem. Yes, guys. Tell me, based on the Lagrange's mean value theorem. Chalo, tell me. Check करें? Shall we check it up? Shall we check it up? Okay. So the Lagrange's mean value theorem. Now let's talk about the function f of x, which is 1 minus x square plus x cube. Once again a polynomial function. Once again what? Once again it is a polynomial function. So hence it is always continuous and differentiable. Since it is polynomial, so it is always continuous and always differentiable. Acha ji. Right. That means it is definitely continuous. That means it is definitely continuous in the closed interval -1, 1. Then it is differentiable in the open interval -1, 1. See, it is always continuous differentiable, but yeah, right. Yeah. We talk about the interest. Mean value theorem, it's Lagrange's. I told you, no, Sunil. Like mean value theorem means the LMVT, Lagrange's mean value theorem only. Right. Chalo. Okay. Now, what is the value of x now? Then what happens? The value of the function should be equal to 0 at some point c. Okay, sorry. Should be equal to what? Should be equal to the fb minus fa is divided by b minus a. fb minus fa is divided by the b minus a. Is divided by b minus a. Now what should be the value of fb? fb means f of 1. A and b is -1 and 1. Minus f of -1 divided by 1 minus -1. Divided by what? 1 minus -1. Okay. Now what should be the value of f1? ये check करते हैं हम लोग. What should be the value of f1? What should be the value of f1? So f1 is fx is 1 minus x square plus x cube, na? The fx is 1 minus x square plus x cube. So what is the value of f1? Is 1 minus 1 plus 1, that is equal to 1. What is the value of f minus 1? Is 1 minus 1 minus 1, that is again -1, right? So what should be the value of f dash x? The f dash x is 1 minus -1 upon 1 minus -1. I've just substituted the value here and this is cancelled out as 1. Now what should be the value of f dash x? fx is given to you, na? Differentiate this. Minus 2x plus 3x square is equal to 1. What should be the value of x? What should be the value of x? You are actually getting 3x square minus of 2x minus 1. 3x square minus 2x minus 1 on this left hand side equal to 0. Solving it up, the value of x should be minus b, that is 2, plus minus under root of b square, that is 4, minus 4ac. So minus minus becoming plus, 4 3s are 12 divided by 2a. So the x is equal to 2 plus minus under root of 16 is 4 divided by 6. 6 by 6 is 1. 2 minus 4 is minus 2. Minus 2 by 6 is minus 1 by 3. So what should be the value of x? 1 and minus 3. What is the correct answer? 1 and minus 1 by 3. So now eventually you don't have the option which is 1. The correct answer is minus 1 by 3, but you should know that there exists a value x equal to c. Okay, x equal to c, which belongs to the interval, you can clearly check the condition of Lagrange's mean value theorem. The x equal to c belongs to the open interval -1, 1, right? So as I told you, the value of x equal to c should belong to the open interval -1, 1. Open interval means not including endpoints. So this one is wrong. The correct answer is 1 by 3 and the correct answer is minus 1 by 3, sorry, minus 1 by 3. Minus 1 by 3. That is the option number B is the very correct answer. Okay. The option number B is the very correct option. The option number B is the very correct option. what is the value of C of Cauchy's mean value theorem for fx equal to e power x and gx equal to e power minus x in the interval 2, 3. Come on, everybody, quickly. Everybody try to sell this one quickly. Yes, guys. Shall we check up? Comment to Telegram. Yeah, I'll share you my Telegram link. Don't worry. So, what is the value of C of Cauchy's mean value theorem for fx equal to e power x and gx equal to e power minus x in the interval 2, 3? Let us check this and put down. Let us check this and put down. So, guys, f of x is e power x, right? So what should be the value of f dash x? The value of f dash x is simply e power x, right? Then what is the gx? E raised to the power minus x. So what should be the value of the derivative? G dash x is minus e power minus x. It is a minus e power minus x. Acha sir, no problem. It's a minus e power minus x. Now, what is next? The value of C for Cauchy's mean value theorem. So, if I want to apply the Cauchy's mean value theorem here, oh, just a second. If I want to apply the Cauchy's mean value theorem here, according to the Cauchy's mean value theorem, we have f dash C divided by the g dash C is equal to fb minus fa is divided by the gb minus ga. Is divided by GB minus GA. Okay. Now, what is FB? What is the value of FB? Ye raha fx. So, e power x. And what is A and B? 2, 3. Okay. So, that is e raised to the power 3 minus e raised to the power 2. GB. G is e power minus x. So, e raised to the power minus 3 minus e power minus 2. Now, do not compute these values using the calculator. You just try to simplify. Now, what is f dash C? E power C. Have a look at this. This pointer is little disturbing. Okay, so f dash x and g dash x is minus e power minus x minus e power minus c, and that is equal to e power 3 minus e power 2 upon, now this can be written as 1 upon e power 3 minus 1 upon e power 2, and this is finally e power 3 minus e power 2. Just simplify this, e power 2 minus e power 3 divided by e power 2 and e power 3 multiply हो जाएगा e power 5. The powers will get added. This eventually becomes how much? ये minus हो गया, and e power minus c goes above. Total हो गया e power 2c, and this is equal to, you take the minus outside, e power 3 minus e power 2 will get cancelled. So minus of e power 5. E power 5 jumps to the numerator. Minus minus cancel, and then just compare the power of exponent. 2c is equal to the 5, and hence c is equal to the 5 by 2. What should be the value of C, sir? The value of C is equal to the 5 by 2. The value of the C is equal to the 5 by 2, right? The value of C is equal to 5 by 2. Okay. Then we have the next question. Consider the fx, which is modulus of 1 minus x, 1 less than equal to x less than equal to 2, and gx, which is fx plus b sine pi by 2x. This is a little good question. It's a little good question. Okay. Then Rawley's theorem is applicable for both f and b with g b equal to 1 by 2. Yeah, LMVT not applicable to f, Rawley's applicable to g with b equal to half. LMVT applicable to f and Rawley's applicable to g with b equal to 1, or Rawley's is not applicable to both f and g for any value of b, right? A good question. What should be the answer? Please try to solve up, right? Okay. Let us check. Let us check. Let us check. What is the answer that is coming? Nishu says C for Chennai. Okay, let's check. First of all, f and g. Step by step. First, let's check for the fx function. First of all, let us check for the fx function. Okay. fx function के लिए check करेंगे. What is the fx? Modulus of 1 minus x. Right. For 1 less than equal to x less than equal to 2. So the range of the interest is 1 less than equal to x less than equal to 2. But everybody, guys, what do we know about the modulus function? What do we about the modulus function? That it is continuous, but it is, चलो पूरा ही लिख देते हैं. It is continuous but not differentiable at what value? You don't have to solve it up. I told you the direct method. At whatever is the argument inside the mod, na, take an equal to 0. At 1 minus x equal to 0. Okay, and that means x equal to 1. Right. Okay. That is x equal to 1. Continuous but not differentiable at the x equal to 1. Acha. Right. Then we can say that the given function fx, number 1, is it continuous in the closed interval? See, the interval of interest is 1, 2. Is it continuous in the closed interval 1, 2? Yes. X equal to 1 pe continuous to hai na, and other points it is anyways continuous. Other points it will show a polynomial nature. Only point was the edge point. Right. So it is continuous in the interval 1, 2. Yes. Right. Number 2. Is it differentiable in the open intervals? And now very clearly remember that the condition for differentiability was open interval 1, 2. Was the open interval 1, 2. Open interval means it should be differentiable between 1 to 2, not necessarily at 1 and 2. Okay, so it is not differentiable at x equal to 1, but no problem. Na? At least it is differentiable at other points. I want only other points between 1 and 2, not including 1. Okay, so yeah, second point is also sorted. Now, number 3 condition. What is this f function? So whether f1 equal to f2, whether the f1 equal to f2, so sir, what should be the value of f1? यहाँ देख लेते हैं separately. f1 is 1 minus 1 का mod, that should be 0. What should be the value of f2? f2 is 1 minus x, ना? तो 1 minus 2 का modulus, that is equal to the 1. That is equal to the 1. So this is wrong. Right, this is not equal. Right, this does not equal. f1 equal to f2, wrong. That means LMVT can be applied. Okay, from here I can say LMVT is clearly applicable without any condition. LMVT is applicable but not Rawley's. The LMVT is applicable but the Rawley's is not applicable. But the Rawley's is not applicable. Are you getting it? So f function is sorted. The f function is sorted. Similarly, we need to sort out the g function. Right? देखते हैं. Just a second. Right. Okay, guys, all cool. Okay, so let's go to the next one. Let us the gx function. What is the gx function? It is clearly mentioned that gx is fx plus b sine pi by 2x. fx plus b sine of pi by 2x. It is the fx plus b sine pi by 2x. Now, fx is continuous and differentiable. देखो, मैंने क्या बोला था? This one is continuous and differentiable. Continuous in the interval 1, 2. Differentiable in the open interval 1, 2. What about the sine function? Right? Yeah, Rohit, you can little try to understand. Huh? What about the sine function? Sine function again like polynomial function, polynomial, sine, cos, exponential. These are the variety of function which are always continuous and differentiable. So this is also always continuous and differentiable, and hence I can say it is continuous in the open interval 1, closed interval 1, 2, differentiable in the open interval 1, 2. Always means I can use any interval, na? Acha. That means when I want to write down the condition for the g function, when I want to write down the condition for the gx function, right? The condition for gx function, it is continuous in the interval 1, 2. Now, what I told you with the continuity concept and differentiability concept, I gave you one point there. We talked about the point there. If two functions are continuous and if two functions are differentiable, so the addition of them, addition, subtraction, multiplication, in तीन चीज की बात की थी, they are also continuous and differentiable. Division का बात भी क्या था, but in the division denominator should not be equal to 0. Let's only talk about addition. So if two functions are continuous and differentiable, their addition is also continuous and differentiable. Hence I can write that gx is also continuous in 1, 2. In 1, 2. Number 2, gx is also differentiable in 1, 2. Okay, ये दोनों तो tick mark हो गए. This is tick mark, this is tick mark. Okay, what about g1 equal to d2? What about the g1 equal to g2? That I have to check here separately. Sir, what should be the value of g1? Right, g1 should be equal to f1 plus b sin pi by 2. X की जगह 1 रख दिया ना? Right. Right, what should be the f1? F1 already we have calculated. F1 was already calculated. देखिए, the f1 was 0 plus b sin pi by 2 is 1. So this is b. What should be the value of g2 now? G2 is known as the f2 plus b sin of pi by 2 into 2. The f2 is equal to 1. F2 is 1 plus b sin pi, 2 to cancel, sin pi is 0, so this is equal to 1. So now g1 can be equal to g2 because b is in my hand, na? For g1 equal to g2, the b can be equal to 1, right? You can try to make b equal to 1, right? So the g1 can be equal to g2, yes, if these two values matches, if b is equal to 1. So this can also be true, right? And if all the three are true, we can say that Rawley's is applicable. Rawley's is applicable. So LMVT is applicable to F. Rawley's is applicable to G with B equal to half. No. B equal to 1. Correct answer is option number C. Rawley's is LMVT applicable to F. Rawley's is applicable to G with B equal to 1. The final correct answer, the perfect answer is the option number C. It is the option number C. All cool? Right. Okay, Joff Airborne. See, that is what, if you want to learn more about the modulus function, I have explained this in the continuity differentiability class that whenever you have a modulus function, okay, whenever you have a modulus function, mod x or mod 1 minus x function, actually it is continuous everywhere. Okay, like this particular graph, if we go back, we have done the detailed analysis in the earlier class, just last week class. You can go through continuity and differentiability concept and question class, right? That this is the modulus x graph. It is continuous everywhere. Okay, it is also differentiable everywhere except one point. Okay, continuous everywhere, differentiable except one point. What is that one point? What is that one point? X equal to 0, origin. This x, this argument equal to 0, right? And then I already exaggerated this problem and told you that whenever you have modulus of something else, okay, like modulus of 1 minus x in this question, kahan gaya? Right, modulus of 1 minus x, modulus function always, modulus 1 minus x function always continuous. Differentiable except at one point. What is that one point? 1 minus x equal to 0. 1 minus x equal to 0, that is x equal to 1, right? So it is not differentiable at x equal to 1, but is it differentiable in the open interval 1, 2? What is open interval? All the points between 1 and 2, not including 1 and 2. So between 1 and 2 though differentiable hai na, is not differentiable at the 1, which is not included here anyways, and hence this condition is true. Hence this condition is the true. Okay, so guys, yeah, that's it for this session. Now next class, that is Wednesday. At the same time, 6 p.m. we'll meet to learn, okay, applications of mean value theorem. Applications of the mean value theorem. Applications of the mean value theorem. Okay. So as you know, the PDF will be shared in my Telegram group. I'll share you the link of the Telegram also if you're not aware. You can join that Telegram, right? And the PDF will be password protected and the password is MVT@1. The randomly framed password MVT@1. Okay, just note down this and the PDF will be opening by this password MVT@1, right? And this is what is the thing. This is the next class on Wednesday. Also, Tuesday, Thursday, Saturday, Sunday, we are having the signal and system class for ECEE and IN students. For other branches also, mechanical civil guys, today itself 8 p.m. you have the strength of material class by Dheeraj Sadana sir. Computer science, you have programming and data structure class by Satya sir. That is also Monday, Wednesday, Friday, Sunday. So guys, lots of sessions, technical, non-technical happening for you in this session. Do not forget to subscribe the channel if you have not subscribed so that you attend all of these classes, okay, with full flexibility. Yeah, about the link of my Telegram, I will definitely share. Just allow me a minute. Just a second. Yes guys, so that's what it is. The link of my Telegram I have just shared. You can join the Telegram group and the PDF will be available there. Okay guys, so thank you, bye bye, stay safe and do take very good care of yourself. See you once again in the next class Wednesday at 6 p.m. and Tuesday 8 p.m. for ECEE IN students. I will meet you in signal and system. That is the question practice on the discrete time convolution. Bye bye, thank you, stay safe.